So with solutions that we're dealing in this chapter, we have different units of concentration. Some of them you've encountered before. Some of them are new to you. For example, molarity, you picked up in Gen Chem 1, where it's the moles of solute over volume of solution. We also discussed mass percent in Gen Chem 1, which is the mass of solute over mass of solution, which is the combined masses of solute and solvent. And even mole fraction is covered in Gen Chem 1 as well, but maybe not as readily. You may know this as the other two, because this is in when we talk about gases and Dalton's law of partial pressures. Usually we introduce mole fractions. So mole fraction is the mole of solute over the moles of solution, which is the sum of the moles of solute and solvent. Now, two lesser known, units of concentration is volume percent, which is similar to mass percent, but instead of masses, you're dealing with volume. So volume of solute, volume of solution. It's like mass percent's sister. And then we have a new one that's like molarity's cousin called molality. Now notice the difference. Molarity is a capital M symbol. Molality is a lowercase m symbol. They're both units of concentration, but molality is moles of solute over kilograms of solvent. So notice the difference between molarity and molality. Molarity is moles of solute over volume of solution. So you need to know the equations for the different units of concentration. Now, three of these you should have experience with from Gen Chem 1, but molality is probably something new that you may have to remember. Again, it's moles of solute over kilograms of solvent. So the units are moles per kilogram, whereas molarity is moles per liter. So now with this, when we're converting between different units of concentration, we have to make certain assumptions based on what we're given. So in a problem, it's going to give you a concentration unit, and we're going to have to convert it to other concentration units. So you got to make the appropriate assumptions in order to convert the units. And these assumptions are important. If you don't remember the assumption, then you're not going to be able to convert to the different concentration units. So we're going to, for example, if we're given molarity, we may have to find mass percent and molality, or we're given mole fraction, calculate mass percent and molarity. So you're going to interconvert between all of these. So here are the assumptions. Make sure you remember them. Again, this is the unit of concentration that you know the concentration of. So for molarity, if we're given the molarity, we need to assume 1 liter of solution. In addition, when you're given molarity, you should also be given the density of the solution as well. You can't convert molarity unless you have the density of the solution. And you'll see why in a little bit when we do some conversions. But again, if you're given molarity, you're going to assume 1 liter of solution. If you're starting with molality, you assume 1 kilogram of solvent. So notice the difference. Molarity, we assume 1 liter of solution. Molality, we assume 1 kilogram of solvent. For mass percent, we assume 100 grams of solution. So again, the assumption is based off of what you're starting with in the problem. And then for mole fraction, you would assume 1 mole of solution. So remember, when it says solution, solution is made up of solute and solvent. So you need to know these assumptions. If you don't know these assumptions, you're not going to be able to convert between the different units. Also take note that with molarity, you're going to have to need the density of the solution as well. Now we're going to look at a problem of converting between the different units. So here we have a 7.9% mass solution of sodium chloride. Answer the following questions. So what's the assumption? Mass of sodium chloride, moles of sodium chloride, mass of solution, mass of solvent. We want to calculate the molality and the mole fraction of sodium chloride. So here there's no molarity, so it didn't give us the density. So in this problem, we're given the mass percent of sodium chloride. So since we're given the mass percent of sodium chloride, the assumption is 100 grams of solution. So if we have 100 grams of solution, our mass of solution is 100 grams. Our mass of sodium chloride is 7.9 grams. So we haven't done any calculations yet, and we're answering some of these. Mass of solvent is, let's see, 92.1 grams. So remember, molality, little m, is moles of solute divided by kilograms of solvent. And mole fraction, which is X, is moles of solute over moles of solution. So we have the mass of solution, we have the mass of solvent, we have the mass of sodium chloride. Now, if it doesn't tell you what type of solvent you use, it's understood that it is water, because we're making an aqueous solution of sodium chloride, so water is the solvent that's used. So in order to calculate the molality, we need the moles of solute and kilograms of solvent. So we can go ahead and divide the mass of solvent by 1,000, and we get 0.0921 kilograms of solvent. And we can find the moles of sodium chloride by taking the mass, 7.9, dividing it by 58.5. We get 0.150. So now we have the moles of sodium chloride and the kilograms of solvent. We can calculate the molality. And we get 1.47. So that's the molality of the solution. Now we need to find the mole fraction of sodium chloride. Well, again, the mole fraction of sodium chloride, we need the moles of solute, which we have, and the moles of solution. So remember, the moles of solution equal moles of solute plus moles of solvent. So in order to find the moles of solution, we need to know the moles of solvent. And solvent here is water. It's understood. And we have the mass of solvent divided by its molar mass. And typically the moles of solvent is going to be a lot greater than the moles of solute. So now we have the moles of solvent, we have the moles of sodium chloride, we can find the mole fraction of sodium chloride. And we get a mole fraction of 0.0257. So that is the mole fraction of solute. Just double check the work. So here we have a concentrated hydrochloric acid solution. It's 11.8 molar, has a density of 1.190 grams per milliliter. Calculate the mass percent, molality, and mole fraction. So I'm going to add a few more things that we need to find. So number 8 would be mass percent. We're also going to need the moles of solvent. Let me squeeze that in right here. All right. So we fill in all the stuff in this table. We can calculate the molality, the mole fraction of solute, and the mass percent of solute as well. So in this problem, we're given the concentration of hydrochloric acid in molarity. So since we're given the concentration in molarity, our assumption is 1 liter of solution. So if we have 1 liter of solution, let me squeeze it right here. Our volume of solution is 1 liter or 1,000 milliliters. So if we know the volume of solution and we know its density, we can calculate the mass of the solution. Secondly, if we know that we assume 1 liter of solution and our molarity is 11.8, we know that we have 11.8 moles of solute, because 1 liter times 11.8 gives us 11.8. Because remember, molarity is moles divided by volume. So moles equals molarity times volume. Since our volume is 1 liter, our molarity is 11.8, we know the moles of solute. So if we know the moles of solute, we can use the molar mass of HCl to find the mass of solute. So the molar mass is 36.5 grams per mole. So again, if we know the density of the solution, we know the volume of solution, we can calculate the mass of solution. So mass equals density times volume. That's how we get the mass of solution. To find the mass of solute, we take the moles of solute, multiply it by its molar mass, we get the mass of solute. So it's 430.7. Now the mass of solution, again, for this, you have to make sure volume is in milliliters because the density is in grams per milliliter. So it's going to be 1,000 times 1.190. So this would be 1,190 grams. So now we know the mass of solution. We know the mass of solute. We can find the mass of solvents by subtracting the mass of solute from the mass of solution. So we have 1190 minus 430.7. 759. And then we'll convert this to kilograms. So now we have the mass of solvent. We can find the moles of solvent. Again, no solvent was given to us, so it's understood that the solvent is water. So remember, mass divided by molar mass gives us moles. Oops. And we get 39.963. So now we have everything that we need to calculate molality, mole fraction, and mass percent. So molality is going to be moles of solute divided by kilograms of solvent. We get 15.54. So that's the molality, 15.54. The mole fraction is going to be the moles of solute divided by the moles of solute plus moles of solvent. Again, this should always be less than 1. And we get 0.228. So now we have the mole fraction of solute, and then lastly the mass percent. So we need the mass of solute divided by the mass of solution multiplied by 100. We get about 36.2%. So again, this is how you convert between the different units of concentration. Next time we'll look at a few more examples and then look at how this is applied to colligative properties.